Again, I'm your host, Leah Rosin, the online editor for Bioprocess International. And before we get started, I want to make just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We've muted the audio lines, but we welcome you to type in your questions for our speaker in the chat window on your screen. After the presentation, we'll begin the question and answer portion, and I'll ask our speaker your questions from the chat window. Your questions in the chat window will only be visible to myself and our speaker. So thank you for joining us today. It is now my pleasure to introduce our speaker, Fletcher Malcolm from Repligen.
Hi, good morning, good afternoon, everyone. This is Fletcher Malcolm with Repligen, Director of Product Management. And today we are here to talk about our 80 centimeter pre-pack columns. And the agenda for this talk is here on the slide. A quick one-slide introduction of Repligen, talk a little bit about our Opus pre-pack columns, deciding between self-pack or pre-pack columns, some applications data, and then wrap up in conclusion. So this is a short overview of our 80 centimeter columns. And to start, we'll just look at the Repligen overview. So Repligen has been around since the early 1980s, and our core business for a long time has been manufacturing recombinant protein A ligand. And we are the largest recombinant protein A ligand manufacturer in the industry. So in addition to that, we also have product lines like our Opus pre-pack columns, our flat sheet filtration technologies, and a variety of other technologies that we sell to the end user community. So from an Opus standpoint, this is a good overview slide. Our Opus columns are configurable with flexibility in resin choice, application, and size. And so that means that you can do virtually the same thing in a self-pack column, which you can get in a pre-pack column from Repligen. And as you can see by the numbers on the slide, we've shipped a large number of columns. And this shows our experience, our breadth and depth of our product line, as well as the acceptance in the industry with now 200 phase 1 to 3 campaigns and 2 commercial processes since we launched this technology in 2012. And so end users, customers are using our Opus columns to increase process efficiency, just like many other single-use or disposable products. Opus columns enable faster campaign turnarounds and come ready to use. Optimizing process economics, we are doing the packing steps for you. That means that you save many hours of time in packing, in preparation for that packing, and all the documentation that goes along with that. And then finally, from a quality and risk mitigation standpoint, we've built our quality system to support column use in the GMP environment. Today, our range of columns looks like this, from 50 microliters now to 150 liters in column volume with the introduction of the Opus 80. And as you can see on the slide, there's many different diameters in between. And our end users choose the diameter, a bed height, which we can configure to the nearest millimeter, and then we pack any supplier's resin. So this makes our columns very platformable across all phases of development. And so specifically, when we think about the 80 centimeter column, what does that give us? And so I put this chart together, looks at bench scale to pilot, early phase, clinical, then to late phase commercial. So just a little scenario that could be typical for a monoclonal antibody type of purification, whereby we have a 5 gram per liter titer, and the amount to purify post-protein A step is shown on the slide in the chart, third row down, and then the column size, sizing it equivalently with a model cation exchange resin with about 100 mg per mil dynamic binding capacity. And you can see that with an 80 centimeter column that the purification horsepower is around 11,500 grams, which means that you can purify in this model as shown, from a harvest from a 2,000 liter bioreactor in one cycle. Or if you have multiple 2,000 liter reactors and willing to run more than one cycle, then the purification can also fit nicely with the 80 centimeter scale. So this gives us additional flexibility, capability for processing large volumes of, product through the 80 centimeter column. And so this usually leads us to this discussion with our customers where we're looking at a pre-pack column versus a self-pack column. So the evaluation criteria are often risk, cost, manufacturing, process, and fit. And so don't have time to go into depth on all of those factors for this presentation, but the summary is shown on the next slide. And these are some of the things that we have seen with our experience in the industry and reasons why end users will end up buying pre-pack columns and move away from self-column packing. So there's economic savings that we can quantify, and we have a proprietary model that we use to help to quantify the specific savings on a case-by-case basis. Driving operational excellence and lean manufacturing principles, essentially making your process simpler by outsourcing the column packing step. Eliminating packing-related risks. There's a lot of nuances that come with column packing, and if it's not an operation that you or your team does frequently, then that can be a potential risk from a product timeline perspective, equipment, etc. So we take that risk away by doing the packing and the difficult work that comes along with the packing as part of our standard offering. Flexible manufacturing strategies. These include things like multi-product or single-use facilities where changeover is often a time-consuming step, and pre-packed columns can help reduce that time. And in addition, they offer a much smaller footprint versus conventional self-pack equipment. And then finally, eliminating cross-product contamination, just like you would with any sort of single-use or disposable product. Our Opus columns, although we don't consider them single-use, we consider them campaign use, are dedicated for a specific molecule, and that helps to eliminate those cross-product contamination concerns. So now that we've looked at, or at least done an overview of self-packed versus pre-packed and understand a little bit of the basics of the pre-packed column, we'll go on to show some Opus 80 centimeter applications data. And the executive summary slide is shown here, and the Opus 80 centimeter column is a direct scale-up of the 60 centimeter design, which is currently on the market, and we launched that in 2016. So the column is 80 centimeter internal diameter. It has can accommodate bed heights from 10 to 30 centimeters, and we pack resin from any supplier. With the development of this column, we spent significant time optimizing the flow distribution system through computational fluid dynamics and experimental design. So I'll show a few slides on that. And in addition, there's no new product contact materials of construction compared to the 45 centimeter or 60 centimeter Opus designs. We use standard connections, and the maximum operating pressure is 3 bar. The design, of course, we've qualified to well above 6 bar, and this makes our columns fit into the normal bioprocessing workflows and conditions that you would typically run the columns. So the column construction, this is just shown as if we cut a column in half. The Opus 80 centimeter columns, just like our 45 and 60, come with a recovery port in the side of the column shown here. They have the inlet and outlet on the top of the column. They have an integral casters and this black top cap and bottom cap to enclose the column shell. So columns are very robust. The plastics are low leaching and Class 6 compliant, and that information is available, or more detailed information is available in our regulatory support file. So the recovery port, just to spend a little bit of a few seconds on that, is designed to remove the resin from the chromatography column once it's packed, and that can be in the event of a deviation during production, or just if you want to get the resin out after use. And so it's a convenient feature to have as a potential backup plan. in production. So back to column design of the flow distribution system. The 80 centimeter flow distributor it's been engineered to design our holdup volume or reduce holdup volume, minimize back pressure, and minimize any uniformity of the support mesh. And so each 80 centimeter Opus column has two flow distributors, one on the top, one on the bottom, as seen in the previous slide. And this flow distribution system we've shown to be extremely efficient, both through the CFD modeling and some packing study data, which I'll show on the next slide. And here what we're seeing is, on the left, a model with an agarose Sephoros 6 fast flow resin, looking at three different diameters, 80, 60, and 45. So these are all Opus columns. Asymmetry and then theoretical plate count measured in plates per meter. And you see that the results of the different scales are very consistent. And this shows the optimized flow distribution system in the 80 is not only efficient but scalable. And then using a different resin, so this is a model polymethacrylate resin, in this case Toyopearl SP650M. Different characteristics for this resin, so slightly different asymmetry and plate count results. And again, consistency from a 10 centimeter column, which is less than a 2 liter column volume, up to an 80 centimeter by 20 centimeter column with a 100 liter column volume. So there's a significant scale-up factor going from the 10 to the 80, and you see the results from plate count and asymmetry very consistent. And so lastly, on the applications data piece, no pre-pack column presentation would be complete without some shipping data. And so this is a test that we run for all of our columns when we introduce a new size. It's called an International Safe Transit Authority test. It's a standardized test. A certified test facility executes the test schedule that's on the slide with high temperature and high humidity, low temperature, low humidity, compression testing, vibrational testing, drop tests, and then 4 incline impact tests, which are the column, the pack column in the crate sliding down a ramp at a given rate of speed, slamming into a steel wall. And so the way the test works is we pack the column here at Repligen, we put it in its qualified crate, send it to the testing lab facility. They do the test schedule shown on the slide. They then return the column and the crate to us, and we test for plate count and asymmetry. And so asymmetry is on the top here, pre-shipping, and then post-shipping, and then plate count is on the bottom. So this is plates per meter, and you see the results pre-ship and post-ship are very consistent, both in asymmetry as well as plate count. So this shows that we can ship columns even in a worst case shipping scenario, and they arrive, they're intact, the shipping crate is intact, and the chromatography bed is intact. So finally, to wrap up this presentation, our columns are packed in our facility in Waltham, Massachusetts, which is just outside of Boston. And we have in this facility 7 packing rooms with multi-dimensional stands. In other words, we can pack many different sizes in our customized packing stands. And we have a large capacity for packing columns, which leads to a 6 to 8 week lead time as our standard lead time. And this is even attainable for the 80 centimeter column. So to wrap up, Opus columns allow unparalleled flexibility, choosing from our variety of different diameters, resin from any supplier, and configuring bed heights to the nearest millimeter. This makes our columns very platformable, and then combined with the value proposition for pre-packed columns, saving you a lot of time, a lot of money, making changeover easier, is a reason to, if you haven't already, look at pre-packed columns for your operations. And most importantly, leave on this last thought is the column packing ultimately is a business that we've built here at Repligen, and your business is to make quality drug product. And so we can focus on the column packing piece and allow you to focus on what's most important for your job. And so with that, I'll wrap up and take any questions.
Great, Fletcher. So the first question is, are these columns used for AAV downstream purification?
Yes, so we do have some columns that are used for AAV downstream purification, not at the 80 centimeter scale, but smaller scale columns, so yes.
And what is your packing limitation with respect to particle size?
Yeah, another good question. The smallest particles that we can reliably pack are around 30 micron now in diameter. Now that depends on the exact resin type, but in general it's the 30 to 40 micron range is the smallest particle size we can pack.
And how much does an 80 centimeter column weigh?
So an 80 centimeter column will weigh, actually I have a convenient chart on that in a couple of slides. So an 80 centimeter column by 20 centimeter will approximately weigh 315 kilograms.
And can the pre-packed columns be reused and stored?
Right, so pre-packed columns, typically our end users are using our columns for campaign use, which often means they are used for a few cycles, then stored maybe for a few months or perhaps for a year or two, then taken out of storage and qualified with plate count asymmetry test, and then reused again for that same molecule. So what we see typically, especially at our larger column sizes, is a cycle of use, storage, and then reuse.
Okay. And what resins can you pack in the 80 centimeter column?
So in general, we can pack the normal resins that we would pack for our other Opus sizes. So that means we have around 100 resins that we typically pack, many different base speeds, as shown up on the slide that I just brought up, many different varieties of affinity resins, ion exchange, and mixed mode resins.
Okay, great. So if we didn't get to your question, we will be providing all these questions to Fletcher, and he can follow up with you directly. So thank you, Fletcher, and thank you to our audience for joining us.
Thank you.
So the recorded version of this webcast will be available for on-demand viewing on our website, and as a registered attendee, you'll receive a follow-up email providing you with a direct link. We look forward to having you join us at future Bioprocess International Ask the Expert webcasts. Look for those announcements in your inbox. Have a good day.